Now we are multiplying and dividing rationals. So rationals, once again, is our fractions, and then we're multiplying and dividing them in different ways. So the key for anytime you're doing this is you want to factor it and then make it all into multiply, and then you can see what's on top and on bottom. Okay, so let's go ahead and might as well factor first. So I'll go ahead and do my work up here. X squared minus 4, that's a difference of perfect squares. So x plus 2, x minus 2 for that one. On the bottom, greatest common factor, we have a 4x plus 12. What do they both have in common? They have a 4 in common. And if 4 times what is 4x? 4 times x. 4 times what is 12? 3. Okay. Divide. And on this, what two numbers multiply to be 6, add to be 5? That's going to be, I just like setting it up here so it's a little easier on the brain process. What numbers multiply to be 6, add to be 5? 2 and 3. 2 plus 3 is 5. 2 times 3 is 6. The last one, what looks like a greatest common factor again. What do they have in common? They have an x in common. X times what is x squared? X times x. X times what is 3x? 3. Okay. Then the rule is you can never divide fractions. You can only multiply them. So I'm going to switch that to a multiply, and then the rule is we flip the second fraction. So we take the reciprocal of the second fraction and change it to multiply. So the first one, I have x plus 2, x minus 2, 4 times x plus 3, times, then we flip the fraction. So that's an x plus 3. On the bottom, x plus 2, x plus 3. All right. So then anything that's on top, well, let's just talk about multiply real quick. When we multiply fractions, we multiply straight across. So it's like everything is on top here, everything is on bottom here. So it's like I can just connect this right here because it's all multiply. Okay, so I have all of this on top, all this on the bottom. We're looking for things in common to reduce out. I'll just go in order. Do I have an x plus 2 anywhere down here? I'll let it finish that parenthesis. Do I have an x plus 2 anywhere? Yep, I see it. X plus 2 and the x plus 2 can reduce. There's an x plus 3, x plus 3, x plus 3. Which one do we cancel? It doesn't matter. This one has to cancel with one of them. And I'll just go ahead and cancel this one right here. Doesn't matter which. Is there an x minus 2 anywhere? Nope. Is there a 4 anywhere on top here? Nope. Oh, here's an x and an x. Can those cancel? No. Remember, this x is trapped by that plus sign. So that x traps that plus sign. It's locked in. So it looks like that's everything we have here. So that equals, what's on top? I have an x times x minus 2. There's that x, there's the x minus 2. On the bottom, I have the 4 and an x plus 3. Okay. Express in simplest form right here. So I was looking. Perform the operation, express in simplest form, meaning they want us to multiply it out. This is an unacceptable answer. It needs to be simplified. So x distributes. 4 distributes. Final answer, x squared minus 2x over 4x plus 12. Okay, should be our answer. X squared minus 2x divided by Let's go ahead and put it in parentheses. Notice when I didn't put it in parentheses, it just attacked this last term here, divided by, so it has to have parentheses. There we go. 4x plus 12. Sometimes with these programs, it's important to get used to the algorithms and the format that they have. Okay. Done exactly the same way as what I did. First thing we do is so the first thing they did is they changed it to multiply. I like just factoring it first so I can see what's going on. Anything different on the next one? Looks exactly the same kind of problem. We got difference of squares, we got a trinomial, greatest common factor, and then there's nothing we can do with that. 8x, it's multiply, so everything on top's on top, everything's on bottom's on bottom. No need to flip any fractions.